Hello, today is 6.4 entropy. Here are three examples of things that are spontaneous. So, spontaneous means it's something that happens without any help. It has a tendency to increase the stability of something by moving it from a higher potential energy to down to a lower potential energy. So, water during a waterfall, it's falling from a height down to somewhere lower and spreading out and having more room. And this ball's rolling down the hill. The water is evaporating and nobody had to do anything. It evaporates over time. Even though these three things are spontaneous, we say, they don't happen to be what makes them spontaneous. So it's not because they're all three exothermic reactions, because only two of them are. So these things were at a higher elevation and they've lost that potential energy because now they're at the bottom somewhere. So that they've lost energy. So now that was considered an exothermic reaction. And then evaporation, the water vapor or whatever fluid this is that's evaporating, now it's in the air and it's a gas. The gaseous state has a higher potential energy than a liquid state. So it was not an exothermic reaction. So most spontaneous reactions are exothermic, but there are a few that are endothermic. So why do these things happen spontaneously? So the answer is the topic of our section, entropy. So entropy has a symbol S, and they think that stands for a French physicist's first name. So it's weird that entropy is symbolized with an S, but that's probably why. Anyhow, it's the measure of the disorder or the randomness in a system. So your book has a few examples. There's these three or it's the same beaker over a period of time. So someone's dropping some dye into a beaker of water that is set there all day. So the water molecules are holding as still as they can and be water molecules. So they're dropping this dye or ink drops down into the water. Now, it is the most orderly while it's still, the dye is in the dropper, and then the water is all by itself in this beaker. But once it starts dropping in here, it starts out, it's all together kind of, but then after 10 seconds, you can see it's spread out pretty good. And then after a minute, it's spread out everywhere evenly. So the whole beaker is red. So that is the least orderly. It was all sorted to the ink was here and the water was here, but now the ink and the water are infinitely mixed up together. Now, the next example it had was this brand new box of matches that you buy at the store, and you open the box and they've got them all nicely arranged. All the wood handles are at one end and the strike match part at the other end. But if you drop the box, if you drop it, then oh no, they scatter everywhere. So now they're all mixed up and they're pointing all different ways. So things just move they always tend to move from a system of being more orderly and to a system that's less orderly. So they were orderly in the box, now they're disorderly on the floor. It could be with the gaseous state also. So here on the left is a valve that's separating two compartments. And on the left side is pure oxygen, the little pink dots. And on the right side is pure nitrogen. And the valve is closed. And so the door is shut. So they cannot move back and forth. They're separated by that valve. But if we twist this valve and open the door, then they can start to freely flow back and forth. And that's what they do. They don't want to stay where they are. Gas molecules move around, and it's just like this liquid. Give it some time and it just starts spreading out. So it becomes more disorganized, even though, it is kind of, it looks sort of organized, that it's pink, green, and pink, green, but it's disorganized because they were all sorted on one side and on the other side. But that just doesn't happen in spontaneously, that gases will sort themselves on the left and on the right by two different kinds. They always just spread out and mix together. So this brings us to the second law of thermodynamics. The entropy or disorder of the universe is always increasing. Now, your book points out that Hebrews chapter 1, verses 10 through 12, are scripture that supports the second law of thermodynamics. It's talking about how God's created everything from the very beginning, and only He doesn't change. But all of us, we grow old, and our belongings grow old, and they fall apart, and but God never changes, and the second law of thermodynamics does not happen to him, but everything else decays and breaks down and will perish. So changes in entropy, we have that delta in front of the S, the symbol for entropy. And on the left are very nicely organized and neatly folded sweaters at a store. And on the right is after Black Fridays happened somewhere at some poor store. I believe it was in Dubai, it said. So this has almost zero entropy on the left, and this has a very high level of entropy on the right. So if entropy is increasing, which it is here, they're very disorganized, then it's positive. But if entropy is decreasing, so that means that it's more orderly, going against spontaneity, or it's negative. So these did not stack themselves and fall like that on the shelf. Someone spent a lot of time making that happen. So that's all I have for section 4. See you all soon. Bye.